Hello all and welcome back. So in this video, let us continue our discussion on trees and now let's write the take input function. So in the last few videos, we were able to define and print our tree. But of course, we define that tree by making the nodes individually and then connecting them manually, right? So ideally, we should not be doing that. We should be making sure that just like we did in linked list, we have a function which we can write which gives takes in the input and gives me out the root of my tree, right? So on that note, let's discuss. We have two trees which are in front of us. Now, in a very similar sense, the way we did for our print function, we will imagine our tree something like this. So our tree is having a root and then it has some children, right? So which are subtrees of their own. Now, once I'm imagining my tree something like this, then again, I can just work on the root node. This is the root node which I can work on. And I can just make sure that all the other taking input is something which recursion is handling. So on that note, what we can do is along with root, the data which we have to add in root, okay, which will be one here, we have to make sure that we ask the number of children because that is how many times I will be calling recursion, right? So in the very first tree here, we see that we have three children. So recursion should be called three times. Here we have two children. So recursion should be called two times. So let us write the code everyone and see. Now let me write, yeah. So I've created a commons file just like we did in our linked list. The reason for that is this is some function which again we will be using a lot along with take input. So as we will keep on writing these functions, we will just make sure that we are basically adding them into the commons file to be used in our future overall codes. So from commons import, I'm just taking print tree detail. Okay, great. So let me actually define that node as well. I forget that tree node. It will of course be there in common as well, right? So that we don't have to define it again and again. Tree node. Cool. So now let us try to define our take input and we will be just getting here we will not be getting anything actually. We will be asking the user at each step. So the very first thing is we should ask for data. Okay. So input, enter the data for the node. Okay. I cannot ask for root here. The reason is I'm going to use recursion. If I ask for root, then going forward, it will always be asking for the root and user can get confused because for the end user, this is just a root, right? These are not roots. It is a root for the subtree, but as a whole, I know that just one, this one is the overall root. Okay. So now once I have this, then I can create a node. So let me create this node. It's going to be tree node with data. Okay. Something which we have seen already. Now, once I have done this, let me ask the number of children as well. It's going to be int input, enter the number of children for, and we can use F formatting here. Again, everyone, I hope you are aware of this F formatting. Must have covered in the previous module where we are able to use these variables inside my print commands inside the string, right? Great. So num children. Once you give me these children, so for each children or each child in num children, I just have to make sure that I take in this child, I take input of this particular child, okay, and I am appending this into children, okay. So this child is going to get changed each time. Yeah, this can basically be done. Here, what is happening? It will define a child, so it will give me a subtree. That subtree I have to make sure that I'm adding in my children. Okay, so pretty straightforward stuff the way we have discussed. Once this all is done, I just have to make sure that I return the node, which you can catch in the root. Okay, so I can take root, take input, something like this. Great. So yeah, I feel this is pretty fine based on the way we have discussed. I hope each and every one of you are able to understand that how we have written this proper code with the discussion. We are just taking the data of our node, then we are defining that particular node, then we ask number of children, and then we are just calling for each and every children. Okay. So recursion is of course coming into play here. And once this all is done, I just return the node. So I will, in a maybe working on this particular root node, I will be adding its children and return that to my user, who can then actually print the same. Okay, great. So yeah, let us see this in action, everyone. How exactly this is going to work. Let me run this particular code. So it is asking me for the data of the for the node, right? Let's define the input which we are going to do, going to give. So let's say we are going to, one second, yeah, we are going to give this input 1, 2, 3, and 4. Okay, so cool, everyone. Let us see this. First, enter the data for the node. It should be 1. One second, I will have to run this. Not here. So because of this, I will have to run this in terminal. One second, everyone. So let us run this in terminal because it is asking for the input. Okay, let me kill this. Yeah, cool. So let me clear all this. Great. Now I think we can see this, everyone. So it's just that it runs in my terminal. So just let me zoom out. In the terminal, it is asking me for the data. So let's say this is going to be 1. Okay. So I've entered 1. Enter number of children for 1. I think it is 3. Okay. So I'm getting an error. One second. For each child in number of children. Okay, my bad. So we have made a mistake here, everyone. It should be actually range, right? I cannot iterate over a list. It should be a range. Okay. So I was actually writing a code for in 3. That is wrong, right? That is not right. So, and also we are not using this variable. So I can just make it underscore. Let me try to clear all this and run it again. So it is enter the data for the node 1. Enter number of children for 1, 3. Okay. So now it is asking me enter the data for the node. Okay. So I think it should be 2. Let me add 2. Okay. Enter the number of children for 2. I know it's 0. Enter the data for the node. It's going to be 3. Enter the number of children for 3, 0. Enter the data of the node 4. Okay. Enter the number of children for 4. So it is 0. Okay. And I am able to see my tree, right? So yeah, I think this is working fine. Just let us do one more thing. Let us try to give a little bit more complex tree as an input to see if it is good in that way as well. So let's say the tree is something like this. 2, then we have 3, we have 4, here we have 5, here we have 6. Okay. So let us see this now, everyone, how we are going to give this as an input. Let me run the code again. Let me clear everything. Great. So enter the data for the node. It's going to be 1. Children of 1. It is 3, right? Okay. Enter the data for the node. Now it is asking me, I think, for 2. Great. Enter number of children for 2. 2 has 1 children. Great. Enter the data for the node. Okay. So is it asking me for, one second. Is it asking me for 3 or 4? One second. Okay. Just give me a minute. Should we enter 3 here or 4? Okay, we are using recursion. So first call would have been made here. Then this would have made the call, right? So it should be 5, I think. One second. 5. Number of children for 5. 5 should have children 0. Great. Enter data for the node. Okay, so again it is asking me. Okay, so this time it should be asking for 6. Yeah. Children of 6 should be 0. Okay, enter the data for the node. Okay, now which node is it asking? Let me see. So recursion would have went here, then it would have gone back. Okay, then gone back again, I believe. 1 second. Yeah. Then recursion would have gone back here as well, everyone. Recursion, yes, recursion would have gone back to this, and then finally it would have returned here, right? So that is how the recursion is going to play out, right? Okay, so it should be, I think, three now. Three are zero children. Okay, so one. Okay, see. Okay, I think I followed everything, but still I have made a mistake. So 1, 2, 6, 3. 2 is 5. And I have made some mistake here because, yeah, so we added zero children for our 5. So let me clear this and do one thing. Enter the data for the node 1. 1 has 3 children. Next is 2. 2 has 1 children. Data for the node. Okay, so 2 children should be 5. That is how recursion is going to work. For 5 again, I should have enter 1. Okay. Enter data for the node. So recursion will go here. It should be 6. Number of children for 6, 0. Enter data for the node. So we would have returned from this. And finally 3, 0, 4, 0. Okay, so now I think it's fine. 2, 3, 4, 2, 5, and 5 as 6. And these are no children. Yeah. So yeah, I think we have took the input, but all of you must have realized one thing, right? While I was doing this, it is a lot difficult, right? It is not very intuitive the way we are taking this particular input. The biggest problem I see is that if someone doesn't know recursion, he will struggle a lot. Okay, you are effectively assuming that your user will know recursion, and that's a very very bad and big assumption to make. So the overall idea or the overall way of taking this input is very bad, because I have to make sure and always remember how these calls are going, right? How these calls are actually happening. And it's fine because I know recursion, but if tomorrow I ask someone else to give this tree as an input, I will have to first teach him recursion. And that I believe is the worst way to handle that simple task like taking input of our function, taking input of our tree, right? So yeah, let us see in the next video if we can just work on this to make it a little bit better again. The idea is that, see, we should be able to do a task, okay, but we should be able to do it in a better way. Right now it is not the best way of doing it because I'm struggling a lot in actually understanding. Even I made the mistake in the very first input while I have an idea of recursion. So when it returned from this 6, it returned all the way to 1, and that is something which I have to understand. Okay, so yeah, we will see in the next video if we can actually take this input little bit better, and if some data structure or something can help us in doing that. Okay, so cool everyone, let's meet in the next video and see how we can improve the way we are taking the input of our function. Though the current one is working fine, we would not like to take input like this which confuses the user. Okay, thank you.